Hey guys, welcome to the channel Unshackling Sudokus and Puzzles. Today's video will be on a Region 51 Sudoku created by Lucy Audrin. So as you can see, the Sudoku is themed around this 51 clue and also the two givens which read 5 and 1. So Lucy also has a blog mindwielders.com where you can check out the Sudokus posted. All the Sudokus posted on the blog have interesting themes and aesthetic designs as well. So please be sure to check out the blog. Many of the Sudokus posted there are really good. So I'll add a link to the blog in the description of the video. And if you want to try the Sudoku yourself that we are solving today, the link to solve is also in the description of the video. Do give it a try before watching the video. You'll enjoy the video even more. So let us move on to the rules of the Sudoku now. Classic rules apply, and then killer rules apply. In all the cells encompassed by dotted cages, digits do not repeat, and whenever there is a clue given inside the cage, the sum of the digits will be equal to the clue. Standard killer rules and little killer rules apply. So the sum of the digits along the direction indicated by the arrow, let us mark those cells maybe. So the sum of the digits along this direction will be equal to 51. There is a small arrow pointing towards this direction, and digits may repeat along the arrow direction. There is no restriction on that. The last part is the XV part. So whenever you have an X symbol between two cells, then the sum of those digits is 10. And whenever you have a 5 symbol between two cells, then the sum of the digits is 5. So negative constraints do not apply, which means that you can have two adjacent digits which sum to X or which sum to 5 without any symbol between them. So these are the rules. This seems to be an interesting Sudoku, so let us give it a try. So we'll quickly write the digits which sum to 5 because the possibilities are limited. So 5 is either 1 plus 4 or 2 plus 3. So I don't think there are any more 5s in the grid. There is a 6 cage, so which means that these two cells must be 2 and 3. And now you'll notice that this 5 cannot be 2 plus 3 because then this cell won't have any valid value. So this becomes 1 plus 4, and since digits do not repeat inside the cage, this cannot be 1 plus 4, so that would be 2 plus 3. Okay, notice that there is something interesting in this construction. So there are 1, 2, 3 and 4 9 cell cages. Okay, you have also a 9 cell cage in 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Notice the corner 9 cell cages. In all these cages, there is something very interesting to notice. I will highlight those cell cages. So you'll notice that these 4 cells are outside, going outside the box 1, which means that whatever cell comes in these, whatever digit comes in these 4 cells would have to go inside these 4 cells, because this is a 9 cell cage and digits from 1 to 9 would be present in this cage, and these 4 cells can't go in these 5 cells because digits do not repeat inside cage. So which means that row 1, column 4 and 5 and row 4, 5, column 1 would have to be present in these 4 cells. The same is true for this cage and this cage. You exactly have 4 cells going outside the box and with 2 cells on each side of the cage. That is a really interesting deduction. So maybe we can make use of that. So 2, 3, 1, 4. So which means that these 4 cells must be 1, 2, 3, 4. So now this 10 cage has to be 1 plus 9 or 4 plus 6 because of 2, 3 here. It cannot be 2 plus 8, 3 plus 7. So the one rules out the one here. So that has to be 1, 4, 6 now because 9 is not possible. So I have a 2, 3 here, I have a 2, 3 here, which means that I can make corner pencil mark of 2 and 3 here. And the moment I do that, you'll notice that this cannot be 1 and 4 because if this is 1, 4, then we don't have enough space for placing both 2 and 3. So which means that this 5 has to be 2 and 3. This has to be 2, 3. And this 10 cannot be 2 plus 8, 3 plus 7 because it's in the same case. So it's 1 plus 9 or 4 plus 6. I have 1 4 here, so okay, I also have written 1 2 3 4 in this 9 cell cage, right? There is also a 9 cell cage in the kind of in the middle. So these remaining digits would be 5 6 7 8 and 9. And you have a 5 here, so these cells cannot take a 5, so that's 6 7 8 and 9. So if I look at this box, all these cells sum to 10, so which means that these cells will take a 5, because 5 cannot go in an X, as you would need another 5. 5 cannot be in this cell because it's in the same cage. 5 cannot go here, so that gives a 5 here. And that removes the 5 from this cell, and that gives 5 in one of these cells. So let us look at the X here. It cannot be 1 plus 9, 4 plus 6. So that's 2 plus 8 or 3 plus 7. So I'm slowly trying to fill all the X's and the 5's, as that would help us in this start of the Sudoku, I think. So if I look at this box again, so this sums to 10, this sums to 10, this sums to 10, and you have a 5 here, which means that these two cells also sum to 10, because in a box, the total sum is 45, and you have totally 35 from this X's and 5's, so these two cells will also sum to 10. So there is a 1 4 here, which means that this would be 2 8 or 3 7. Okay, there is a 4 in row 4, which means that one of these cells would take a 4, and that removes the 4 6 possibility from here. Nice. So this becomes 1 plus 9 now. Can't be anything else. So 1 9 and 2 3, which means that this would be 1 2 3 9. Okay, so these two cells sum to 10, which means that these two cells will sum to 5, right? Because you have a 2 digits summing up to 10 and 2 digits summing up to 5. So which means that if there is a 10 total from here, so there would be a 5 total from here. So which means this would be 1 plus 4 or 2 plus 3. But you can't have 1 plus 4 because there is no 4 in these 4 cells. So which means that this would be 2 plus 3, and that has to be 1 plus 9. So 1, 2, 3, 5, 9. So these cells, this is also a 9 cell cage. So this becomes 4, 6, 7 and 8. The remaining digits in the cage. This can't be a 4 because you have 4 pencil mark here. So that becomes 6, 7, 8. So which means that these two cells sum up to 10, right? So that has to be 4, 3 or 2. 2, 3, 4 corresponding to this 6, 7, 8. And now this 10 cannot be 2 plus 8, 3 plus 7. It's 1 plus 9 or 4 plus 6, right? So we're getting a lot of pencil mark, guys, and not even one digit so far. So I think we need to write some more pencil marks. So there is a 2, 3 here and a 1, 4 here. So this would be 5, 6, 7, 8, 9. 1 and 9, 2 and 3. So this would be 4, 5, 6, 7, 8. Okay, there is a 9 going here, so which means that 9 cannot be in row 6. So 9 must be in these 3 cells, right? So either in this cell or this cell. So which means that I can remove the 9 from here, right? Because if I have a 9 here, then there is no space for 9 in box 5. So that's not a 9. So I'm certainly missing something here. So what is this 10? Okay, lots of possibilities. It could be 2, 8, 3, 7, 4, 6 now. So we haven't yet looked at this cage at all. Okay, this cannot be 1 plus 9, guys. This is a superb deduction. So if I have a 1 and 9 here, this is either 1 and 9 or 4 and 6. But if I have a 1, 9 here, in column 1, I can't place both the digits 1 and 9 because 1, 9 gets removed from these 5 cells. I'll use a different color. 1, 9 gets removed from this 5 cell, and you'll notice that in column 1 there is only one cell which can take 1 and 9. So this cannot be 1 and 9. A very nice deduction, sharp one. So which means that this has to be 4, 6, right? Can't be anything else. So the moment it becomes 4 and 6, I can remove the 6 from these cells. So that's 5, 7, 8 and 9, which means I take a 6 in one of these cells, and that removes the 6 from here. So that's not a 6. Okay, it's not helping much. So there is a 5 pencil mark, corner pencil mark here. So which means this cell is not a 5. So that's 6, 7, 8, 9. Okay. So 4 and 6 cannot go into these cells now because I have 4, 6 here and it's in the same cage. So which means that in column 1, 4, 6 must go into these 3 cells. Which means I can remove the 4, 6 from here. So that's 5, 7, 8. And this 5 removes the 5 from here. So that's 7 or 8. So which means that this X cannot be 4 and 6 now because 4, 6 is going here. So this is either 2, 8 or 3, 7. So you have a 2, 3, 7, 8 quadruple and that becomes 4 and 6. Superb, guys. So it all started here. A really powerful deduction. So which means this is 4, that is 6. And there is no 6 here. So that's a 4, 7, 8 triplet. Wow, we have the same deduction that we used earlier. So we removed the 9 from this cell, right? So now we'll see that 6 cannot be in these cells, which means that you can place a corner pencil mark of 6 in these cells, right? So I can remove the 6 from here because if that's a 6, then 6 gets removed from all these 3 cells, so that is not a 6. So that's a 7 or 8, and you have 2, 3, 7, 8 here, and you have a 2, 3, 7, 8 here. So we are forming a quadruple, so which means that the remaining cells in that row must be 7 and 9. We can form a pair 7, 9. Sorry, 2, 3, 7, 8. It must be 6, 9, right? So there is a 6, 9 pair, which means that this cell cannot be 6 and 9. So that becomes 7, 8. And we have a 7, 8 pair here now. So I'll remove the corner pencil mark. 6, 9. Okay, 7, 8 pair inside the cage. So which means that this is not a 7, 8. So that becomes 5, 9 and that becomes a 6 because it's in the same cage. So that becomes 9 now. So we got a 5, 9 pair here. So that removes the 9 from this cell. That's a 6, 7, 8. So 1, 5, 6, 9, 2, 3. So that has to be 4, 7, 8. So again we have a 2, 3, 7, 8 quadruple in row 5. Which means that these cells has to be 6 and 9. Okay, so you will have at least exactly one of 7 and 8 here, right? It is either 2 plus 8 or 3 plus 7, which means that one digit out of 7 and 8 is going here, and you have one more digit out of 7 and 8 here. So this forms an invisible pair 7, 8. So these two cells can't take 7, 8. So that has to be 2, 3, 5. 1, 4, 6, 9 and 7 and 8. So that's 2, 3, 5. So 4, 6, 5, 9, 2, 3. So these would be 1, 7, 8. And this can't be a 1, so that's 7, 8. So 1 goes in one of these cells. So if I look at column 1, I have a quadruple 1, 4, 7, 8. So that has to be 6, that has to be 4, which means that's not a 4. So that is 7 and 8. So 4 must go in one of these cells. So 6 gets removed from here, and that puts the 6 in one of these cells. So 6 is not going anywhere here. Okay. So this is not 1 or 4, which means I can remove the 1, 4 from here, and correspondingly I can remove the 9 and the 6 from here. So it's either 6 plus 4 or 9 plus 1. Okay. So 1, 2, 3, 4, 7 and 8, which means this would be 5, 6 and 9, and 9 is removed from there, so that's a 5 or 6. So if I look at row 1 now, there is only a few possibilities for 1. 1 cannot be in column 2, so 1 has to be in this cell or this cell. So I also can make use of the fact that we deduced earlier. These 4 cells must go into these 4 cells, and I need to place 4, 6. So 4, 6 cannot go here due to this 4, 6. So which means this would be a 4, 6, and that has to be 2, 3, 7, 8 pertaining to these 2 cells. So I have a 2 3 7 8 quadruple now. So this has been the recurring theme here, guys. So in column 3, if you notice, there is a 2 3 7 8 quadruple. So this cell would be 1 or 9. So I have a 2 3 here, which means the rest of the cells can't take a 2 or 3. So 2 or 3 has to go either here or here. And this little killer clue has way too much freedom to even think about looking at it, guys. This is not the point to look at. If you look at these cells, none of the yellow cells have been placed, and they are not even close to telling us how to continue. So let us continue on with this killer and XV part. So 2 3 must be in one of these cells. Can I have a 2 3 in this yellow cell? So let's see what happens if I have a 2 or 3 here. So I have a 2 3 pair now, so which means that these two become 7 8, and which means correspondingly these two become 2 and 3. Okay, that is not possible. That's not possible. Super. So when I have 2 or 3 as candidates here, so I get a 2 3 pair, right? So that becomes 7 8, and that becomes 2 3. Now you will have 3 instances of 2 and 3 in those cells. That's not possible, right? So which means that my 2 3 cannot go in the yellow cell, and the 2 3 goes here, and which means that the 1 has only one option now, so 1 has to go here, and we are getting some digits now. So that's a 9, that's a 1, that's a 9, that's a 1. Superb. Really nice way to look at the Sudoku here. So I have a 2 3 pencil mark here, and looking at this quadruple, I know that there will be one of 2 3 here and one of 7 8 here. So which means that there is a 2 3 invisible pair. Okay, so 1 4 6 2 and 3. So this would be 5 7 8. And this has to be 5 7 8 and 9, right? Because 1 2 3 4 and 6, so that would be 5 7 8 9. You have a 5 9 pair here, so that's not 5 9, that's a 7 8. Okay, so if I look at this cage now, I have 2 3 7 8 here. So that is forming a quadruple, and 1 4 6 here, which means that these two cells must form a 5 9 pair, and there is only one cell left for the 9 in the cage now. So that's a 9, that's a 5, and these cells can't take a 5, so that gives 7 8 9 triplet. Superb. So which means that these two cells must be 5 6, and because of the 5 here, so that gives a 5 here, a 6 here, and that resolves this 4 6 pair. So which means these two cells cannot be 4, so that gives a 4 here. Okay, that's nice, guys. So I have 5 6 staring down at this cage, which means that this cell would have to take the 5 because it has to contain all the digits from 1 to 9. So 5 goes in this, and 6 goes somewhere here, right? Which means that 5 and 6 cannot be in the rest of the cells. So that's not a 5. That's not a 5 and 6. That's 4 7 8. So you have a 7 8 pair here, which means this would be a 4, and that has to be 5 6. That would be a 5 and a 6. Okay, so now this can't be 4 and 6 anymore. You have the 4 here, so that would be a 1, that would be a 9, and that resolves this 5 9 pair. And because of this 5, you get the 6 here, and that gives a 5 and a 6 here. So 1 6 9 2 and 3, which means that this would be 4 5 7 8, and there is only one cell left in box 8 for the 5, so that has to take a 5. That's not a 5, that's 4 7 8, and almost everything is done now, guys. So we have got marked, except this box, we have marked every cell with pencil mark or a digit. Excellent, right? Still the Sudoku has not yet been over, and I think this will provide the final touches to the Sudoku, guys. So let us see if we can place some more pencil marks in this cage. So you have a 1 9 here. These 4 cells are the same as these 4 cells, so 1 9 cannot go in row 8, so these two cells will be 1 and 9, and these two cells will be 2 3 7 and 8. Pertaining to this 10, so that would be 2 3 7 8. So I have a 6 9 pair here and a 1 9 pair here, which means that in column 7 and 8 I can't have any more 9s, because you have 1 9 here and 1 9 here. There will be only 2 9s, so that's not a 9, so that becomes a 9 here. So that's a 7 8 pair. So you have a 7 8 here, you have a 7 8 here, so that's not 7 and 8, which means that this is not 2 and 3, because these two cells sum to 10, right, because of this x. So if you have 2 3 here, that has to be 8 or 7. So there is a 2 3 pair, 1 5 6 9, so that has to be 4 7 8. So I'm getting thrilled now, guys. Even this box is getting slowly filled with pencil marks. Look how the author has chiseled this Sudoku, guys. It's not easy to construct like this. Not restricting the ability to get all the digits all of a sudden. So the Sudoku so far has given only pencil marks, carefully controlled. So 1 5 9 2 3 6. So that has to be 4 7 8. So which means that there is a 4 7 8 triplet here, because we know that one of these digits would be 7 or 8. So 4 7 8 5 6 and 9. 1 2 and 3. So that has to be 1 2 3. There is a 1 here, so that's a 2 3. So 1 and 9, 4 7 and 8, 2 and 3. So these two cells would be 5 6. So every cell is filled with a pencil mark, guys. Every cell. Now, can we look at this 51 clue? This still looks ominous. There doesn't seem to be anything here, really. So I have a 2 3 5 triplet in row 6, which means that this must be this cannot be a 2 or 3, so that would have to be 7 or 8, which means that correspondingly that becomes 2 and 3. So that gave us something. So can we use coloring here, maybe? Okay, so first I'll remove the colors along this diagonal. I don't think it can help us yet, because there are simply too many possibilities here. So let us see if we can do something with the Sudoku. So let us start using coloring. So we'll use two different colors for 2 and 3, and we'll use two different colors for 7 and 8. Let's see if that's giving us something. So that's a red. That would be yellow. That's red. That would be yellow. And so one of these would be yellow. I'm not certain which one. And one of these would be red again. The coloring seems to stop here. Maybe we can try out for the 7 and 8. So if that's a 7 green, that would have to be blue color maybe. Okay, I'll use something lighter. So this would be this one. So, and there is a 7 8 here. So that's a green, and that would be this light yellow, you can say. So that is, this one also would be okay. I'll use something different, guys, because both of these look similar, the yellows. So I'll use the blue. So this would be green, and the blue goes somewhere here. Okay, again we seem to have hit a roadblock here. So I'm not able to continue the coloring, so I think this clue would have to help us some way. So what do we do now? Let us try to add all the totals here. What is the maximum possible sum here? So 5 plus 8 would be 13. 13 plus 8 is 21. 21 plus 11 is 32. 32 plus 5, 37. 37 plus 17. That gives us 54. Wow. Okay. I didn't think that this clue would be helpful. Look at this clue, guys. If you add all the maximum possible values along this total, I'll add once again. So 13 from here, 21, 21 plus 11, 32, 37, and maximum total here is 17. So 37 plus 17 is 54. You will see that each entity along the diagonal has a degree of freedom of 3, which means that if the maximum total is 17 from this box, you can have a minimum of 14. You cannot go anything lower than that, because that would contradict the 51, which means that this cell cannot be a 1. So that has to be a 9. So that will be a 1. So which means that these two cells cannot be 1. So that's 2 3 4. So you have a 2 3 pair here. which could have been noticed earlier too, so which means that's a 5 and that's a 4. I didn't see this one, so that has to be 1, 2 and 3. So can we carrying on with our chain now? Okay, so we can use some shading now. So that's a red, that's a yellow. So 1 is in one of these two cells, which means that this cell cannot be 1. So that's a 4, that's a 1. So let us use the idea that we saw earlier. So you can't have anything going lower than 3 degrees of freedom. So if you have 1 here, that will surely violate the total, right? So this cannot be a 1, because whatever the maximum possible value is there, 8 is the maximum possible value. So you need to have at least 5 here. So 1 is certainly eliminated, that's not a 1. So that gives a 1 here. Superb. So digits are tricking down now, so which means that this is not a 1, so that's 2, 3, so that's a 1. And that helps on with our coloring now. Superb guys, superb. So that is an yellow, that is a red, and that is yellow. Okay, beautiful. A really superb creation guys, simply superb. So that's, okay, I need to have red here, but red cannot be here, so that's not 2, 3, so that would be 2, 3 now. Okay, which means that that's a red. Oops, that is a red. And that is yellow. Okay, so I think we have managed to color in everything here guys. So all the reds would be same and all the yellows will be same. Okay, so I have a red in row 5 and I have a red in column 2, which means that this would have to be the red, just using simple classic rules. So that's 2, 3, which means this is 7, 8. Okay, so 2, 3 pair, so that's not 2, 3, so that's 7, 8, and that's 2 and 3, so that would be the final yellow, right? So we have 2 more here, so that's yellow and that is red. So let me quickly look if all the reds and yellows have been placed correctly. Red, yellow, red, yellow, red, yellow, red, yellow, red. Okay, yeah, they seem to be correct. So I think we can place the 7, 8s now, right? Because we have got a lot of 7, 8s. There is a 7, 8 here, which means that this 7, 8 would be the opposite of this. That's a green. So that is a green. That's a blue, green. A quiet exercise that I can do here. So that's a blue. That's a green. That's a blue. So that's a green. That's a blue. There is a green here, so that's a blue. So green cannot be here, right? Because you have a green here and a blue here, which means that this cell cannot be green or blue. So which means that this would have to be a 4. Super. So that becomes a green. So this would be a green. That becomes a 4. That's not a 4, and that becomes a 4. Wow, superb guys. Look how the Sudoku is looking now, right? So you placed all digits that could be placed, and this is not also a 4, so that's 7, 8, and that has to be blue. And that has to be 2, 3. That has to be yellow, right? So look how the Sudoku is looking guys, right? I think this 51 will surely provide the final touches now. So there is no way to resolve this Sudoku without this clue now. So beautiful. How the theme has come to help us. The 51 clue is helping us now. So let us add the digits now. 5 plus 5 plus 9 is 19. And we need 32 from this diagonal, right? Oh, yeah, I have a 5 here. I could resolve this 5, 6 pair, right? Let me do that first. So that's a 5, 6. And this 6, 9 pair is resolved. So that's a 6, 9. And okay, that stops right there. So now surely I think this clue should help, because all the candidates left are only 2, 3, 7 and 8, right? So I'm not sure how to resolve this yet in a meaningful way. Okay, we have 3 blues and 1 green, right? So so 5 plus 5 plus 9 is 19, and if I have 3 blues, which means all those are same. If I have 3 sevens, 21 plus 19 is 40, and this is opposite of the 7, so that would be 8, so 48. And maximum I'll be getting okay, 51. I can get 51. So what happens if this is 8? If the blues are 8, 3 multiplied by 8 is 24, and you'll have a 7 here. So 24 plus 7 is 31, and 31 plus 19 is 50, and 50 plus 2 is 52. Okay, awesome guys, this is awesome. So I can't have blues as 8 because of the coloring. We know that all these 3 cells are going to be same, and this cell would be opposite of that. If I have 3 8s in the blue, then the total is going to 52. Minimum total you will get is 52, which means that all the blues would have to be 7. Superb guys, and with that we'll complete the Sudoku, I think. So all these blues has to be 7. You can write blindly. Awesome, really awesome guys. So now if you add the total, so let me put the greens as 8 now. That would be 8, that would be 8, that's an 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 8. So all the greens would be 8. And now let me add the total. 5 plus 7, 12 plus 7, 19 plus 8, 27, 32, 41, 48. So that has to be 3. Beautiful. So let me just look at the total again. 21, 29, 32, 39, 46, 51. Okay, this has to be 3. And now all the yellows are 3. So I can write blindly all those digits. And all the reds remaining would have to be 2. Awesome Sudoku guys. Really. And with that, we have completed the Sudoku. Just one word, a mind-blowing creation. So you can imagine how the rest of the Sudokus of Lucy would be. So do check out the blog. Hope you had fun watching me solve this tremendous creation. All the variants equally helped us in the solve. The XV constraint helped, the killer constraint helped, even the little killer at the end of the solve helped us to resolve the 2, 3, 7, 8 pairs. Hope you guys had a lot of fun watching me solve the Sudoku. Please let us know your thoughts in comments, and do share the video around, and remember to subscribe to the channel. We hope to see you soon with the video. Take care until then. Bye bye.